Okay. Now, just now, before the break, we cover what happens if you pull one object or push one object, it will affect another object, right? So the next session, now we look at relative motion of two particles when you observe from somewhere. So, for example, I'm walking in the class, but both of you still working also, walking. So I need to know what is the relative velocity between you and me, while both of you still moving. Okay, as what you see on the screen here, you have observer, and then you have point B. So let's say you have a particle B is moving in a blue line. So B is moving, and then observer A is standing, is looking at B. So when you are observer A, you look at B, yes, B is moving. So there is a reference vector towards B. You have RB. All right. And A also moving now. We have another friend who is also moving, or we call it translating observer. So this A also moving, object A also moving. So when you are stationary, you observe A, you have another vector called RA. So actually you're observing, let's say you are the fixed observer, you're observing A and B. So you have two vectors, one is RA and RB. And then the one A, translation observer, you can also relate the speed between A and B. The speed between A and B as both objects are moving. We label as RB stroke A. Okay, a cheat code to break this vector RB stroke A, memorize, transfer, stroke become negative sign. You can write RB minus RA. This is just a cheat code. Of course, it involves a lot of explanation on mathematics. We won't go do it that way, right? You can ask your mathematics lecturer to explain, but we are more in application of equation. All right, so back to our screen here. So you have three vector, RA, RB, RB stroke A. RB stroke A means the position of B relative to A. This stroke is relative. RB stroke A means position of B relative to A. Okay, relative B relative to A. And this is a vector form. You see the arrow? The vector form, actually it forms a triangular vector. So triangular vector, you can draw and derive the relationship between the R vector. I already give you the cheat code on the screen, on the whiteboard, right? So you just use that. But it depending, this one is just, we assume that RA is your, RB stroke B is your resultant, not resultant, but it's the, it form this triangle. Okay. Okay, the rest you read, On the screen here, you also observe that you are given x, y, z location and x prime, y prime, z prime. So later when you solve relative motion between two bodies, label carefully on the object. You label x, y, z for fixed point or fixed observer, and you label x prime, y prime, z prime for observer that is moving. Okay, then there will be one object is your target. So the question for 1.8 section, you always see 3 points or 3 objects. One is fixed, one is moving, two is moving, and then one is observing. Okay. So you label O, object A, object B normally. Huh? So the fixed observer always we refer as a reference point or O, right? Okay. So again, using vector, RB equal to RA plus RB if you form the vector triangular. But most of the time, you will get, if you hold R stroke B, you move RA to the left, you get RB minus RA. Okay. So R is a position. So how you get velocity? You get the time differential, R dot. It become R dot B, R dot A, and R dot B stroke A. Okay. So you come VB plus VA plus VA stroke B. Acceleration same. You change the velocity to acceleration. Make sense? Okay. Let's look at how we apply the vector equation. So example 18, if the train was moving, train travels at a constant speed 6 km per hour. If we tell you train travel at a constant speed, what happened to the acceleration? Acceleration will be 0, because constant speed. But speed here is the magnitude of that vector. Okay, velocity, you have magnitude and direction. Magnitude of velocity is speed. So this is just a magnitude. It doesn't tell you the direction. And cross over a road. So as you can see on the screen here, the train was moving from left to right, and you're given the XY axis. So if you see XY without the apostrophe or the comma, it means that is the reference point for you, right? So it's moved to the right or along the x-axis, 60 km per hour. If automotive A, which is you see on the screen here, traveling at 45 km per hour along road, this one, and the angle between this road and the train track is 45 degree. So label the object as x prime, y prime. So when you see x prime, y prime means this is the moving observer. Right. Determine the magnitude and direction of the velocity of the train relative to the automotive. Train relative to automotive. Train relative to automotive. Okay. We have two solutions. I give you two. I'll give you first one first. Vector analysis. So relative velocity of train to A is measured from the x prime, y prime axis. So you write the first equation. Vt equal to Va plus Vt stroke A. Or you can start to write the equation that I write on the screen. All right. So you can write Vt stroke A equal to Vt minus A minus Va. Okay. Same meaning. Right. Then you start to use vector form. So this one you use Vt equal to Va plus Vt stroke A. You translate them into vector form in ijk. So Vt is moving to the right along x-axis at 60 km per hour, magnitude 60 in I direction, in x direction. So you translate 60 km per hour to the right in x direction, you write as 60I. VA, how do you write VA? How do you write VA? Huh? You know there's a 45 degree there. Okay. Is that that? What about Y direction? Just now you mentioned 45 cos 45, right? That is only x. This vector going this way, your vector can break into x and y. Plus, you should have plus 45 sine 45. G. Okay, 45, this vector break into x and y. So 45 cos 45 I plus 45 sine 45 y. Not y, j. Make sense? Okay. So like what I explained just now. So you have 45 cos 45 cos 45 I plus 45 sine 45. Okay, again, remember to break your vector into reference axis. Plus VTA, right? Because this is what you want to find. Velocity of train to the automotive. So you press your calculator, rearrange the equation. I and I you combine. Right, you move this one negative already, right? So 60I minus 45 cos 45, you get 28.2I. Then this one 45 sine 45, you get 31.8J. This is the answer for this tutorial question. Okay, this is solution 1, where you use vector analysis, you use IJK, you split into x and y, or you use IJ vector identity. All right, you should able to find the resultant vector for train to A, right? Square this one, square root. And then you should able to draw the vector for this one, right? I and j, this is negative. So it should be going that way, going down. Going this way. Can you understand what I'm trying to say? Nico, you understand? What I mean by positive I? Nico, what I mean by positive I? If you draw vector, how do you draw? This is x direction. You draw 28.2I, right? This is your y-axis. How you draw negative 31.8? What is the resultant of these two vectors? Huh? Like that, right? Or you move this one to here. This is your resultant. This is your angle. Okay, so the question didn't go more, but we come to test or exam. We try to give you some marks to solve. So normally we'll ask you to find the velocity, magnitude, and direction. Okay. Okay, this is what I mentioned just now. So you draw the vector diagram, 28.2I to the right, and minus 31.8 go down. This is the resultant. So angle is this one. You should able to find the resultant vector and the angle. Use trigonometry. In this case, you use tangent. You inverse the tangent, you get 48.5. Okay. So when you solve this kind of question, remember to give the diagram, draw on your solution, mark where is your theta. Okay. Any question? Any question for example 18? Good, huh? Okay. Example 19. So you have two aircraft that in the air show, you have two aircraft that is passing each other. So as you can see, you have a reference plane and also the translating plane or the translating object. So okay, you read the question. Plane A flying along straight line path. So there's a first plane that is moving in a straight line. In this case, in y prime axis. When you see I prime, means this is the translating object. In straight line, 17 I kilometer per hour. With the where B is flying along circular path. Circular path. When you see circular path, recall back all you learned in your circular motion. You need to draw your tangent, normal steps. The radius is 40 kilometer. Determine velocity and acceleration of B as measured by pilot A. This is what? Acceleration of B measure from A. Means you are A, you're measuring B. You are A, measuring B. Yeah? All right. Now, how do we solve this kind of question? So you look at the diagram. This reference axis X and Y, X prime, Y prime. One is linear motion. Distance between two is 4 kilometer. Curvature motion. You're given acceleration, kilometer per hour square, pointing this way. All right. So velocity, before you solve velocity, pay attention to the axis. Where is the origin? In this case, on the diagram, you see X and Y. And relative motion is referring to object A. So on the diagram, you see X prime, Y prime. So there are two vectors, vector A and vector B. Vector A is more than vector B. Vector A is more than vector B. So vector A is 700, vector B is 600. So the length of vector will be different. And then this is the velocity of B to A. Okay, this is how you draw the vector diagram. It's not always triangular. This case is straight line. Okay, so you write the vector equation. VA equal to VB equal to VA plus VA stroke B. Or you can use the cheat equation. You write VB stroke A. You refer to what the question will ask you. Acceleration of B as measured by pilot A. So VB stroke A. You put in the value. You get V stroke A equal to minus 10 kilometer per hour. Or you translate to a positive value, you become the negative sign, the opposite direction. Okay, so means that if you are A, you look at B, you are actually seeing B is moving back, right? Because you are faster. You move at B, you're faster. You're actually seeing B is going behind. Right, so you get negative sign. Acceleration. So plane B have both tangential and normal component. So as I draw a red arrow on the screen, so recall how to find normal acceleration by this v squared over rho. Do you remember? Yeah. So what is VB? VB is the tangent velocity. Tangent velocity. So substitute, you have the rho. Substitute, you get 900 kilometer per hour square. This is how you apply when you learn about the acceleration in the normal and tangent section. Straight away call the equation. Although the v squared divided by rho was not given, but every time you see curvature motion, curve, straight away write the equation, the equation for acceleration. Then you will see, or actually all the information given, just substitute. So again, you need to solve the relative acceleration. So VB equal to VA plus VB stroke A, or you can write AB stroke A equal to VB minus VA. VB stroke A equal to AB minus AA. Then you can still get the same answer. Okay. So what is VB? Acceleration of B is 900 in X, 100 to Y, correct? VB. You know that normal, you calculate already, right? Normal is 900. X is I. So 900 I. You're given in the question, acceleration go back. Y is negative, so negative 100 G. This information was given in the question. So pay attention to that. Then this one, VA. VA only move in the Y direction. So 50G plus the relative motion. A, B stroke A. You combine I and I, J and J. Move this one to here, negative. So you get 900I negative 150J equal to A, B stroke A. So you have I and J, you can find the magnitude and direction. Okay. So this is in vector form. Again, you can find the magnitude and direction. I'll give you the final answer. Okay. This one is go down from x-axis. Okay. So when it comes to your tests or final exam, always give us or tell us where do you refer to, especially angle. Okay, or in the diagram, you can draw this angle in the diagram. Okay, with this we conclude chapter 1. Our time is until 10. Okay, let me stop the recording.